The VPI Unipivot tone arm, which has been available for years now, is a popular tone arm for a good reason. It sounds good, it's widely available, it's relatively inexpensive, and has wonderfully friction-free bearings. There is, however, one point about all unstabilized unipivots that leaves performance on the table. What do I mean by that? So every tone arm has to have a vertical moment of freedom and a horizontal moment of freedom. These are essential to be able to track the record and track the groove across from the outer area of the platter to the inner area of the platter. But there isn't any need for the moment of freedom that rocks back and forth. It's that axial rotation that is common to unstabilized unipivots. This third moment of freedom offers an opportunity for the tone arm to rob energy from the cartridge. I'm not saying it makes it sound bad. I'm just saying it's leaving performance on the table, so to speak. So the fix for this is to install VPI's Dual Pivot. Unfortunately, many people who have tried to install this on their own have been experiencing mixed results because there is no way until now to be able to measure what is the frictional force that has been placed on that pivot. A lot of people don't realize that they've put so much force on that pivot that the arm, frankly, just doesn't want to come along for the ride. So I'm going to show you how to properly install this dual pivot. I am certain it will elevate the performance of your tone arm for a relatively inexpensive price. So you'll need 3 parts in order to install this dual pivot properly. Obviously, you'll need the dual pivot assembly itself, made by VPI. Next, you will need the counterintuitive that's made for the VPI Unipivot arm by Soundsmith. This is an inexpensive but incredibly useful device that goes on the counterweight to be able to change both the tracking force and the force that we're going to put onto that dual pivot with small, controllable, repeatable increments. And then lastly, the third item that we're going to need for this installation is the Wally skater. The Wally skater measures, amongst other things, frictional force, and that's what we want to keep under control with this dual pivot. I'm not going to go over all of the steps that are in the written instructions that come with the dual pivot. I'm going to concentrate instead on the steps that aren't written in there to make sure that you get the last measure of performance from this arm. Before we install the dual pivot onto the pivot housing, let's just get a baseline for the static friction of this tone arm, because that's what we're going to have to control here, that we don't put too much force on that dual pivot that makes it too difficult for the arm to track the groove. So let's get an idea of where we are as a starting point. So now we've set up the Wally skater for the static friction test. Please refer to the video entitled Measuring Tone Arm Behavior to ensure optimal performance on the YouTube channel for a little bit more on the static friction test. But you will have to have the tone arm set at its optimal tracking force. You'll have to have the stylus about 2 to 3 millimeters above the platter and begin the test. All right, as we can see, we're starting with about 1% horizontal torque force native to the arm. That is not a problem whatsoever. And I'm going to be sliding the hanger over to see how much force we need to put on the arm before it begins moving. Here we go. Basically immediately. 1% at best. Make sure that you install this dual pivot as close as possible to this side weight here, but not touching it. And I recommend that the side weights get screwed all the way in. We don't want to leave the possibility for any chatter between the side weights and the dual pivot housing. Some of you have side weights like this one that don't screw in and or out. Please be very careful that, 1, you're very gentle with that pivot point, and 2, some iterations of this tone arm have made it actually rather difficult to be sure that we are getting right into the center of that bearing. So make sure that you have truly centered this arm on that bearing and aren't sitting outside of that receptacle cup. If you can feel it. As you can see, I got the stylus guard on right now, and I recommend that you keep it there for a little bit. But right now, we're just going to look for roughly level head shell. And we accomplish that by tightening or loosening this set screw, which comprises the dual pivot. As I screw it in, it's going to lift the arm in this direction. As I screw it down, it'll allow it to move the opposite direction. For now, we're not going to worry about maximum channel separation. That is the ideal azimuth angle. Right now, I just want you to visually align for roughly level head shell. Measuring for your ideal azimuth angle, that is maximum channel separation, is always the last step you do in the setup process. Refer to our video on our YouTube channel named WallyTools Cartridge Setup Process, an overview for details. Okay, so now we've roughly visually leveled the head shell by changing this screw here, which determines the vertical position of the dual pivot. Now, our next step will be to set the targeted tracking force. Make sure that the counterintuitive is in the center of the range. That gives us the best flexibility to start working with it. And of course, as you position the eccentric weight this way, it's going to put more mass on that pivot point, and this way it'll put less mass on that pivot point. In fact, you can see now, because I've twisted this way, the dual pivot is no longer in contact with the plate. That's an undesirable situation for us. We want it to remain in contact, but not too forcefully. So right now I'm going to set this counterweight and screw down that set screw so that I know that the pivot is in contact with the plate and there's not too much force on it, because I can take my fingers like this and just with a little bit of force I can lift it up. All right, so let's start in this position. I'm going to lock that down and now go to measure tracking force. So now the stylus guard is off, so we need to be extra careful. The cueing arm is up to help protect the cantilever. And we can note now where the counterintuitive is on the front back axis, because that defines our tracking force. So we can see where this should be set, as is right now, for ideal tracking force. We are going to be rotating it like this to experiment with the force that is being placed upon the dual pivot. But let's not move backward and forward any longer. This is now, the set screw for the entire counterweight is now tightened down real nicely and will not, hopefully, have to be moved again. Okay, so now it's time to make sure that the frictional force we've put on that dual pivot isn't going to impede the behavior of the tone arm. This is where so many people have failed with the installation of the dual pivot. And this is why we need a tool like the Wally Skater to measure that frictional force for us. So I'm hoping to see no more than 2 to 3% more static frictional force than what we initially measured on this tone arm before we installed the Unipivot in the first place. If it is more than 3% difference from our baseline test, we need to reduce the amount of force on that dual pivot by adjusting the counterintuitive. All right, let's see how much additional torque force is needed to get this arm to move laterally now that we have the dual pivot properly set. First, I'm just going to give the arm a nudge, make sure it falls back into its neutral position. All right, and let's start giving it a little push real slowly. Oh, that's excellent. Maybe 2% extra. That's completely acceptable. Depending on how much isolation your turntable has from structural vibrations from the rack, the floor, the walls. Some of you may have your listening room in structures that are wood frame and have quite a bit of give to the floor. These environments will have a lot of structural energy bouncing around the floor and the walls and ceilings. And this condition can create a lot of mechanical vibration that the tone arm will see. I just want to make sure that there is enough force on that dual pivot to make sure that it doesn't chatter when you play. To test for this condition, put any record on the platter and start the motor. Lower the stylus down to the run-out groove and let it ride in the end of the run-out groove. Lightly tap on the plinth. Walk around your rack and listen. Do you hear the pivot chattering? This is what it sounds like. If this condition exists, you will have to add just a little bit more force on that dual pivot. Now, I would highly suggest that every 6 months, or at very least once a year, you get the Wally skater out again and retest the static friction that's on that dual pivot. The reason is that over time and use, we can expect that that dual pivot will start to etch the plate. As it etches the plate, it's increasing its surface area, and that can change the friction. So we want to make sure that that dual pivot maintains its relatively friction-free nature. And as always, if you've got any questions, feel free to reach out to us by email or by phone. And of course, enjoy analog forever.